Hi, everybody. We're going to go ahead and get started. Thank you so much for joining. This is one of CompuScholar's monthly teacher success webinars, and today we're going to be talking about teaching programming using the Unity IDE. So by way of introductions, my name is Chris Yost. I'm the president of CompuScholar. I happen to be nursing a bit of a cold at the moment, so I apologize for any coughing that might come through. I'm working the cough drops here madly in the background, so I appreciate your patience there. I've actually spent quite a few years as a software engineer, writing code, owning a consulting firm, conducting interviews, and that sort of thing. So that's the perspective that I've brought to CompuScholar and to the curriculum. So if you can think of anything that you need to talk about with me, I do encourage you to reach out to me to email, and the email address is right here at the bottom of the screen at chris.yost@compuscholar.com. Okay, before we really get started, just a couple of logistical notes. We've muted all of the other participants, so there's not going to be any background noise from anybody else. I do encourage you to ask questions throughout, so if you can think of a question, just go ahead and drop it there in the chat window, and I'll take a look at that and answer those questions just as soon as I can, so don't be bashful there. We are recording this session, so the recording of the session will be posted online, and in the unlikely event there's any sort of technical difficulties, we will continue to record offline and then post the remainder of the session as well. So if we happen to get cut off for any reason, just look for the remaining recording afterwards. Okay, so let's move ahead. This is, as I mentioned, part of our teacher success program. So we do want to partner with you and provide professional development and enrichment opportunities that make your life better. And so as part of that, we definitely encourage you to send us suggestions for topics that we can talk about during these monthly webinars. We have posted our list through the end of May on our teacher success page at CompuScholar.com. So please do go check those out and sign up for those additional sessions. But if there's something else that you'd like to see, certainly let us know and we can work that topic in. All right, so what are we going to talk about today? We'll explore the concept of using video games at a high level to teach coding. We'll introduce you to the Unity IDE and kind of describe what Unity is all about. And then we will escape the PowerPoint here and actually do a live walkthrough of the Unity IDE and show you some things, show you some code, show you some parts of the IDE, and answer your questions throughout. And then, as always, we'll reserve a few minutes at the end for the CompuScholar forum. So we'll make a few brief announcements. And if you have any questions about CompuScholar or other courses that you didn't get to ask earlier, the CompuScholar forum would be a great place to do that. Okay, so why would you want to teach video game design? You know, we're always looking for something that is of interest to our students to teach. And sometimes just doing boring command line IO type stuff the way we did it back in the 80s is not necessarily the way to get them hooked into computer science. So today's kids are obviously immersed in video games from their smartphones to their PCs and their gaming consoles, and there's seemingly games at their fingertips everywhere they go. So they're pretty enthused about video games to start with. And at least when I was growing up, and from a lot of the kids that we've talked to today as well, it's not uncommon to want to be a video game programmer when you grow up. So a lot of kids are going to have stars in their eyes, and they really enjoy playing video games. And by extension, they think that being a video game programmer would be the coolest possible career that they can imagine. And we certainly do want to encourage that. But here's the secret. When you're teaching video game design, at least if you're doing it through CompuScholar, then you're actually teaching coding. All of our video game classes, including our Unity class, are coding classes that are coding-centric. So we are teaching kids to write code and all the classic computer science concepts that go with that, but we're doing it in the context of video games. So for example, if you need to figure out how to dump a bunch of objects onto the screen, we might teach you the concept of loops so you can create new objects in a loop, and that sort of thing. And even though students are unlikely to end up working for one of the major video game companies when they graduate, they are certainly graduating into a field, a computer science field, that is great job market and very high demand, very high paying. So I was in this position myself as a teenager. You know, myself and a group of friends, we really wanted to be video game programmers. We talked about it. And we all went into some computer science in some form and fashion, and none of us ended up working at that, you know, imaginary video game job. However, we all graduated into computer science as software engineers and are very, very happy with the results. So the video games is a hook and a lure. If you happen to be mentoring a student that creates the next Angry Birds, then that's great for those students, and hopefully they will remember you fondly as a percentage, and maybe they'll even remember CompuScholar fondly as a small percentage of that. So don't tell students that they can't do things, because somebody is going to come up with the next cool Angry Birds or Candy Crush or something like that. It's just not necessarily something that we demand of students in order for them to be considered successful. For us, successful is getting them into the coding industry and as a software engineer. And then at that point, the world is your oyster. And if they end up doing video game design or any other sort of software engineering, then that's great news. Okay, so we have chosen Unity as our most recent, newest course. And Unity, frankly, is just super popular. I've stolen this graphic that we're looking at here from the public relations page. It shows that 34% of the top 1,000 free mobile games are made with Unity. And the only thing higher would be a variety of in-house proprietary type stuff. But in terms of general purpose gaming frameworks, Unity is clearly the top dog. I've seen other estimates that suggest, outside the context of mobile games, that Unity might be up to 40 or 45% market share in terms of the engine for making those games. So this is not something that they'll learn and then throw away. It's certainly something that if they are interested in video game design, long-term, it will serve them very, very well. So it is, as I mentioned, the most popular video game design platform on the market today. It has great support for both 2D and 3D games, and you can create games for all the major platforms, from PC to smartphones, iOS, Android, tablets, all the major consoles. There's all sorts of great stuff that they support in terms of the platforms. And it does come with just a ridiculous amount of features, from the IDE to the scripting to the physics engine, and much, much more. So I did want to give you a super brief tour of the Unity 3D website. So let me flip out of the browser here and come on over to the Unity website. Let me get back up here a little minute. Just go to the home page. Okay, so we're now at unity3d.com. You can see they're usually pushing their latest version of the IDE. You can click on products and take a look at the things that you can download. There are sample solutions that have been made, so you can browse through that, and you can see all the different types of features that they're pushing, like monetization, augmented reality, virtual reality, and that sort of thing. So there's a lot of very advanced features here. And then when you're ready, you can just click on Get Unity and download it. They've also got an asset store where you can come in and purchase blocks of assets that people have contributed. So this might be sounds or graphics or something like that that you can then plug into your game. So there's a lot of great stuff here on Unity, the Unity website. And I should mention they have a very robust learning area as well. I can get to it. It keeps wanting to put me back at the store. There we go, Learn with Unity. So a lot of tutorials, both video tutorials and otherwise. And so if there's a particular topic that you want to learn about, you can certainly dive right in here and get that figured out. Okay, let's switch away from the Unity website and see what we've got next. All right, so we are finally through with the PowerPoint, and we want to get to the good stuff, which is an actual live demonstration of the Unity IDE and the coding environment. So let me switch over and do that. I'm going to go ahead and actually minimize the PowerPoint here for just a moment. I'll minimize a few things. I'm sharing my desktop here, so hopefully nothing too embarrassing will pop up. All right, so this is the kind of the opening page of the Unity IDE. I'm just going to go ahead and create a new project, and we'll make it a 2D project. We'll call it soccer, and click on Create Project. And we'll sit here and let it grind for a minute as it creates this default project. And what it's doing is it's actually creating a directory under the location that I specified. So if we go back over here and we take a look, there should be a soccer project. Here we go. And so this is our default project on the file system. And this is the default empty project in the Unity IDE. So the IDE is quite powerful, and it may look overwhelming. I will also note that the IDE currently does not have a way to adjust the font size. So the font size is a little bit small here, even for me. I'm hoping it comes through well enough on the recording. So I apologize in advance, but there's nothing we can do about the font size at the moment. So what we have over here on the left is a tab called the hierarchy. So all of the game objects and the sprites and that sort of thing that you place into the game will show here in a tree. This main scene area in the middle is where you build your game. You can see how it looks. And then there's a game tab that will actually show you the running game output. You've got an inspector window over here that will let you see properties of things that you have selected in the hierarchy. So if we click on the main camera, for example, here's all the different properties of the main camera. At the bottom, we've got a project tab that shows us all of the shared assets. So in Unity, an asset is a shared resource like a sound or a graphic or even a script that can be applied in different ways to your game. So what I'm going to do is just switch over to my file system really quickly. I've got a couple of images that I staged here, and I'm going to copy them into the assets folder of our new soccer game. Excuse me. And now you can see that those images have shown up here. So in order to actually create a sprite, we're just going to drag the ball here onto the screen. And you can see that there's a ball sprite that is shown up now in a hierarchy. If we click on it, you've got all of the properties over here of the ball in the inspector. So position and size and rotation and that sort of thing you kind of get by default. So Unity is a very object-oriented framework, and so this plays very well into your object-oriented programming class. An object like a sprite can have a number of different components associated with it. So let me start off and just go ahead and run the game here. So this little arrow at the top will run the game. So I'm going to click on that, and you can see it switches over to the game tab, and nothing happens at the moment. We haven't really added any behavior to the game. So let's stop that. And let's add a component and see what happens. I'm going to add a 2D physics rigid body component. So now this ball object has a rigid body component, and this is what puts the sprite under the control of the physics engine. So any object that has a rigid body attached to it will participate in the physics engine, and there's some default gravity here. So if we just go ahead and run the game again, you can see the ball will take off down the screen under the control of gravity. Excuse me. So we haven't written any code at this point, but we've been able to put a graphic on the screen and put it under the control of gravity and see it fall down the screen, just using kind of the built-in Unity stuff that's part of the IDE. So this is something obviously that's got a lot of great instant feedback for kids where they don't need to learn to write tons and tons of code before they actually get going and they see something on the screen. All right, so let's go ahead and create a secondary platform here. I've got a little grass image, so let me stick it down here. And let's run the game again and see what happens. All right, the ball's going to fall, and it just goes straight through the grass because you haven't set up any sense of collision detection yet. So the Unity physics engine has a great way to do collision detection. I'm going to come back here to the ball object, and I'm going to add another component, physics 2D, and we're going to do a circle collider because this is primarily a circular ball. So we'll do that. You can see a little green outline there around the ball. So this shows you the collision boundary for the ball. We can run it again. And the ball still is just going to drop straight through the darn grass because we don't have a collider on the grass object. So let's select the grass. I'm going to add a component, physics 2D, and we're going to do a box collider to match the shape of the grass image. Now we're in business. Let's run it again. All right, great. So the ball hit and it just kind of stuck there. So the collision detection is now working, and the Unity physics engine won't let you move these objects through each other because they each have a collider on them that is reacting in the physics environment. Now the ball didn't bounce very realistically, so we can fix that pretty easily as well. I'm going to come down to my assets area and create a physics material 2D, and we'll call it Bouncy. Right? So with this Bouncy physics material, if you look up here in the inspector, you can see it's got settings for friction and bounciness. I'm just going to go ahead and change the bounciness to 1. And what we want to do is put this bouncy material on the ball. So I'm just going to drag it up here, drop it on the ball. And if we click on the ball and come back to the inspector, you can see somewhere, here we go, that the bouncy material has been attached to the circle collider. So now let's see what's going to happen. Whoops, I apologize. I shouldn't have actually done that while the game was running. Let me do it now that I've stopped the game. Now it's bouncy again. All right, I'm going to run it. Great. Now you can see that the ball is bouncing much more realistically, and that's kind of what we wanted to see there with that soccer ball. So again, Unity's got a lot of great things that you can do without writing any code. And this is a very object-oriented system. So you've got game objects here on the left. Those objects have a number of sub-objects that you can see in the inspector here on the right. You can add those components. Go ahead and stop them. All right, so that's what you can do very easily without writing any code. But our goal here is obviously to write code, and the whole theme of the webinar was about writing code and teaching programming skills using this environment. So how do you write code? In Unity, a code file or an object is actually an asset. So you can come down here to your assets and create a CSharp script. So CSharp is kind of the way that most folks are going to program in Unity, although it supports JavaScript as well. And we'll just call this the ball script. It's not very creative. Excuse me. So now we've got a ball script here as well. And again, I should mention, if you have any questions, don't be bashful about just shouting them out there in the chat window, and I'll take a look at that. Okay, so what we want to do is then take a look at our script. So I'm just going to double click on the script here, and the Unity IDE, when you install it, will actually come with a secondary IDE for code editing. So this is MonoDevelop, which is a code editor that runs both on Mac as well as Windows and Linux and that sort of thing. So it's very, very flexible that way. And you can see we've just got a default script here in the editor. So again, scripts are assets. You can see we now have a ball asset here in our project area. And you can come in here and just start adding some code. So let's add a simple statement, debug.log, I'm alive. And I'm going to straighten out my curly braces a little bit. My personal preference is to have them vertically aligned, so that keeps me sane. All right, great. So a default script has a couple of functions. One is start. The start function will be called automatically by the framework when the object first loads. So as you might expect, we're going to print out a debug statement that says I'm alive when this ball object loads. The update function is actually called once per frame. So if we wanted to do something every single frame, then we would do it there in that update method. So let's save this and then switch back over here to the IDE. So this is a common pattern where you've got both IDEs up and running at the same time. You don't have to close out one or the other. Whenever you save your work here in MonoDevelop, the Unity IDE over here will pick that up automatically. So let's take a look at the console here. So this is where we would expect our debug output to go. I'm just going to start this very quickly and stop it again. And so you'll notice you didn't see anything here. We wrote the script, but the script won't actually run until you attach it to an object. So all these scripts sitting down here are just kind of passive assets. And if you want the script to run, you actually need to drag it up here and attach it to at least one of these objects. You can attach one of these scripts to more than one object if that makes sense in your game. So I just drug the script on top of the ball, and then you can come over here to the inspector and take a look down at the bottom, and now we have a new component that's the ball script. So the ball script is attached to the ball, and the ball is in the scene. So now those update and start functions will get called at the appropriate times. So let me switch back to the console and just run it again. Great, and you can see that our output shows up there as expected. So this is a real simple way to actually start writing some code. It's almost the equivalent of your hello world that you would do in a vanilla programming class. All right, so let me flip back over to the IDE again. Now, the cool thing about this system, again, is it's very object-oriented. You're doing full C# programming. And so you can see, for example, that our ball script by default will inherit from a Unity class called MonoBehavior. And it's MonoBehavior that has the base versions of the start and the update and a bunch of other functions that you can override. So when you start talking to your kids about object-oriented programming, you certainly have some built-in things that you can talk about and demonstrate inheritance and that sort of thing. fact, let's go ahead and add one more function here. We're going to do a void on collision, enter 2D. That function takes a collision 2D object. Let's call it other. Okay. So as you might guess, this function will get called every time the collider object that's attached to the ball here actually touches something. So let's just add a different debug message. Debug log ouch. Okay, so every time the ball collides with something, we'll expect to see ouch there in the window. Let's save that. All right, let's come back over here and run again. And you can see at the bottom here, every time the ball hits, it will go ahead and print ouch. So this is a super easy way to do event-driven programming. We just add the collider objects or the collider components to our sprites, and then go into our script and override that on collision function. And then you can take certain actions within your game whenever the objects were collided. So again, you can talk about writing functions, you can talk about event-driven programming, you can talk about inheritance and polymorphism. There's all sorts of good stuff here that you can drill into just based on this simple script. And certainly in our own Unity game programming class, we'll go through all that in a pretty careful sequence, kind of building all those concepts from the ground up. And again, the coding pattern is very easy. The student will just write code here in the window. And then you switch back over here and you can run it and it will take effect immediately. So it does a pretty good job of keeping things synced up. If you want to write scripts that do not inherit from mono behavior, you can certainly do that. So you can create your own generic CSharp objects that do just about anything you want to and plug those into your game. So that's pretty standard stuff. All right, just checking my notes here to make sure I cover everything that we want to cover. Excuse me. All right, so one thing that you'll notice is you've got standard syntax highlighting. So strings are one color, function names and objects are another color, keywords are another color. So it has all the conveniences of a modern IDE. If we take off a semicolon, for example, and then we try and build it, let's go build all. You'll see that it says, hey, you've got a semicolon inspected, and kind of highlight that in red until you fix it. And you won't actually be able to run over here in the IDE. Let's go back over here and try and run it. And you can see it's not gonna let you run until you fix all of your compile time errors in your code. So come back over here, add that semicolon back in, and build all. All right, and now the error's gone away. All right, very good. Okay, so I see a question coming in about debugging. What debugging facilities does the IDE have? So it's a great question. So there's a fully functional debugger that's built into MonoDevelop, and it's a little bit interesting because there's actually two different IDEs here, right? You've got your IDE for the code, and you've got your IDE for the game framework where the code is actually running, the scripts are actually running. So what you have to do is a two-step process. Actually, first, let's go ahead and just set a breakpoint here. And then you want to start the debugger, and this will actually connect the debugger in MonoDevelop to your Unity IDE. So we haven't run the game yet. The game hasn't started running, but we just connected these two IDEs together for the debugger. Now, if we start up the game again, it's going to take a few seconds to start up because you've got that debugger attached. But as soon as you hit a breakpoint, you can see the windows flashing down here, and the game is frozen, and we're sitting here broken at this statement, and you've got the standard, continue, step over, step into, step out of functions, so you can step through your code line by line. I have not declared any variables, but if you had variables in here, you could obviously inspect the contents and that sort of thing as well. Let me kill that. All right, and we'll come back over here. Oops, I need to continue. There we go. And we'll stop the game. So again, I've stopped the game, but the debugger is still connected to the IDE. And let's go ahead and do one more thing. Let me show you an exception. So exceptions happen to the best of us. Let's write some code that will cause an exception. Game object missing equals game object dot find. Right, so this statement just goes off and looks for a game object named cleat, and we don't actually have a cleat here in the hierarchy. You can see I just have a ball and grass, but I don't have a cleat object. So this is going to end up null at the end of the day. I've got log missing dot name. Right, so I'm going to try and dump the name property on this game object out to the console. And clearly there's going to be a null pointer violation right here because this missing is going to end up as null. So let me save this. File save. All right, let's come back over here and run it. And again, it's taking just a few minutes here because we had the debugger connected. So you can see no reference exception, and it's broken right here where the exception happens. Let me actually, let's go ahead and run this again. So you can see the framework will catch that exception as well and dump it out to the console here. Let me disable the debugger real quick just so these things will work a little bit faster. So let's run this again. All right, so we hit this exception right away. And if you click on it here, you can see it actually is going to tell you the file and the line of code where it happens, ball.cs line 13. You can even double click on the exception here, and it will take you right to that file and that line of code where you can then go try and fix the problem. So to summarize, that was a long-winded answer to the question about debugging, but there's some great debugging features built into the IDEs. You can set breakpoints, you can manage exceptions, you can step through code, you can inspect variables, you can do everything that you would expect to do from a modern IDE. Let me go ahead and just delete that code in case we want to run it again later. So I'm going to file, save. All right, so I've gotten rid of the exception. Okay. So again, this is fully featured C#. So anything that you want to teach that you would teach in a normal programming class, namespaces, variables, loops, arrays, functions, file I/O, all that stuff is available to you here the same way it would be in any other programming environment. So it's just a matter of coming up with games that will force the kids to learn these skills in order to improve the games. And so that's the approach that we take in the Unity class. Is we'll start them off for the first couple of chapters, just getting them used to the Unity IDE and letting them drag and drop stuff and play with the physics engine. But pretty quickly, we start getting the kids to write code in order to actually improve the games. So if you want to do things like put a sprite under keyboard control or trap mouse events in order to do something, then you need to write code to do that. And we'll show the kids how to do it in the context of that game. So that tends to be a pretty popular approach. You can see up here, you have access to the .NET framework if you want to use that. The Unity engine namespace is the main namespace for all of the Unity widgets. There's some additional ones, but this is kind of the main one that defines mono behavior and that sort of thing. Now, documentation, there's really good documentation online. So we can go help Unity API reference, and it's going to take us back to the Unity 3D website. And here's their reference guide. There's actually kind of two different sections to it. There's the scripting API. So this is a traditional reference. You can see mono behavior is already searched for here. You can click on mono behavior and you can see a full description of the properties and the methods on that object. So you can search for anything that you want to in terms of the reference material. You can also click on manual, and off to the left, there's a series of walkthroughs and just overview guides on these different types of topics. So here's a section all about 2D gameplay, the physics engine, all about scripting. So there's a lot of good stuff here online with the Unity manual. So definitely have your kids take a look at that as well. All right, I want to spend just a few minutes. I'll do a quick demo of some of the games that the kids are writing in our own Unity game programming class. Let me see, file, open project. We can show RoboDash. Just letting it reload here. So RoboDash is a side scroller game that we set up over a couple of chapters with kind of 2.5D backgrounds. You'll notice the parallax effects. Go ahead and just run it real quick. So you can see it's kind of a typical platformer where you can move around with a keyboard control, shoot stuff, and try and stay alive. So you can see the platforms are moving at different speeds than the background, and so it kind of gives it a 3D illusion. Let me stop that. You can see there's a number of different scripts here in the game. So, we'll build this up over a period of time. Again, and by the time the kids get here, they'll have the C# skills necessary to write code that's moderately complex. And we'll walk them through all this. But we need the laser beam, for example, to do certain things when you start. Every time you update, we're going to look and see if it's gone off the right side of the screen and destroy itself. Right, so there's all sorts of pretty straightforward code that the students will write in order to get the behavior of the game objects to work out correctly. All right, so that's just one example project. Let's see. I can show you Thunder Road as well. Apologize for the time here. It just takes a few minutes to get things started up. All right, and let's run this. So this is a kind of a typical top-down racing game. So we've introduced the students to keyboard control and collision of different types, with different types of objects. You can see at the top they're counting damage and speed and time and that sort of thing. So there's a lot going on here that the students have learned by the time they get here in order to script up this kind of behavior. All right, we can open a different project. So we'll take a quick look at Deep Space 2. So those of you that are familiar with asteroids, kind of the classic drive around and shoot at the asteroids game, will notice that Deep Space 2 is obviously a clone of that. I'll just go ahead and fire it up real quickly here. All right, so this is pretty straightforward asteroids clone. You don't want to get hit by the asteroid there. And last one we'll look at is Banana Breakout. So as you can see, at least in our Unity course, the kids are doing many different games. This is just a sampling. They will typically work on something that is different in every chapter. Sometimes we'll take one game and stretch it over 2 or 3 chapters. But with 20-something chapters in the course, there's quite a few different things that the kids are working on. So this is just a simple breakout game where you've got bananas instead of blocks, and you've got a monkey jumping up there to get the bananas when it hits the trampoline here at the bottom. So this is one of the earlier games, but as you might guess from looking at the 2D array of objects up there, that we've started talking about loops and that sort of thing at this point, because they'll use those loops to actually create the objects. All right, so that is a quick walkthrough of some of the games. Are there any last minute questions before we switch out of this and wrap up the presentation? Yes, so there's a question on pricing and licensing. I should have mentioned that when I went to the Unity website. Let's go back over here, click on products. So there are actually 3 different versions of Unity that you can use. There's a free personal version, so beginners, students, and hobbyists, and we find that most people are comfortable using that. You'll want to read the licensing terms very carefully and make sure that you qualify for that. If you are more serious about it, they have a subscription at a couple of different levels that give you some additional features. By and large, students don't need those features, but again, you'll want to read the licensing terms for Unity very carefully and make sure that you pick the appropriate license for your situation. I believe they do have a either free or very nearly free version of Plus for educators. So if you're in a school system and you decide after looking at the licensing that you need a non-free version, I believe you can actually apply for and get a free Unity grant essentially from the Unity store that will give you a properly licensed version. It's beyond the personal version, but they'll get that for your students. So that might be something you'll want to look at if you're in a school system where that makes sense or that's required. and I believe there's a link to that in our installation instructions for the Unity IDE. So thank you for that question. All right, let's go ahead and see if there's anything else that we wanted to talk about here. I think we were about done. So, okay, right. So let's spend just a few minutes in our CompuScholar forum and make a couple of quick announcements. Again, if you have any other questions that are not Unity specific, you're welcome to shout them out here at this time. So our teacher outreach is ongoing here in the middle of the school year. You should be getting email from your customer service representative on a periodic basis. That email will likely give you some sort of insight into how your class is doing based on the metrics and the reporting that we have. So take that opportunity to, respond to the CSR rep, let him or her know how it's going. We encourage you to have a good relationship there. If there's any problems that we can solve for you, please don't hesitate to ask us. We'd be happy to do that. Next is a big announcement we just rolled out about a week ago. We've actually gone through our Java programming lessons, both Java Abridged and Java AP, and we've added new in-lesson exercises to nearly every lesson. So those of you that have used some of our courses like Unity or Web Design or Digital Savvy will notice that in those courses, just about every lesson has this blue Work With Me area within the lesson that gives the kids some ungraded immediate exercises in order to complete the coding for that particular topic. So that's something we've now gone back and retrofitted into our Java class. The Java class already had some of those, but we are now essentially a 1-to-1 ratio where every coding lesson where it makes sense, there is a direct programming exercise that the students can complete. So we're happy about that and starting to get some good feedback about that. Question about the CSharp course. So we do have a Windows programming CSharp course. That course had a comparable number of exercises to the Java course, meaning there were probably 15 to 20 of those exercises scattered throughout the lessons. We are working on that course as well. So expect sometime, hopefully in the spring, we'll have a follow-up announcement for the C# course that will just kind of roll out the same kind of in-lesson work with me exercises for the Windows programming with C# course. So thank you for that. And then just looking ahead to next month's topic, we're going to talk about web design with HTML and CSS. So for those of you that have never done web design before, we're actually going to just pull up a simple text editor and start pounding out some HTML and show you how easy it is for your kids to start creating some graphical things and some formatted web pages that they can look at right there on their computer. So web design is a great way for students to get some immediate visual feedback without having to worry about compilers and that sort of thing. So we'll talk about web design in February. And again, we have a full list of topics that are now posted on our teacher success page at CompuScholar.com. So I encourage you to go over there and take a look at those and sign up for those additional sessions. And again, if you have any suggestions on that, let me know. Okay, so if there are no other questions, I haven't seen anything else come in here. Do appreciate your time today. If you can think of any follow-up questions that you would like to ask, or if you're watching this on the recording, definitely shoot me an email, give us a call. We're happy to chat. Thanks so much for your time today, and we'll look forward to seeing you next month.